Okay, so I'd like to start by saying thank you everyone for coming. Today we're talking about advanced part modeling, and I call it advanced part modeling, but really we're going to focus on some of the things that we don't cover in our essentials webinar. So tools, outside of the typical extrude, so revolve, sweeps, lofts, derived features, shells, and just some more advanced part modeling features than we cover in our essentials webinar. So for those maybe that have a few hours, bit of time in Onshape and trying to understand some of these other commands to allow them to build more complex shapes. So advanced part modeling, as I always say with these webinars, we really encourage you to ask any questions that you'd like. I have the questions dialog up here. Feel free to type in any questions in your in your GoToWebinar dialog, and I'll do my best from time to time to stop and address those questions. So again, feel free to ask any questions you'd like. I'll do my best to make sure they're addressed. If I don't get to your question, stick around. I'll make sure before I close things out here today that I have them all answered. So let's dig in. Now, there are a few things I like to cover about Onshape in general before we get into the topic of the day. And one of the first things that I like to mention is our mission statement. And that is getting everyone working together with CAD on any device, anywhere. And this includes mobile devices. So if you haven't downloaded the Onshape app from the Apple iTunes Store or from the Google Play Store, it's a free app and it's a full functioning CAD system. So you can not only just view or mark up, but you can actually build sketches, parts, features, and assemblies. So it is a real full functioning CAD tool on a mobile device, whether it's Android or iOS. So if you haven't checked out the mobile apps, I definitely would recommend it. Also, if you haven't shared your document, another aspect of this is working collaboratively or working together with other users. Definitely recommend sharing your document. A lot of the benefits of Onshape come in when we start, talking about real-time collaboration between users and comment capabilities and all these neat integration for our collaboration that's really never been done before. So everyone working together with CAD on any device, anywhere. That's our goal. Now, the other thing I always like to point out is we do consider ourselves professional 3D CAD. And when you think of professional 3D CAD, it's really three pieces: parts, assemblies, and of course, drawings. And we do have all three major pieces that make up that professional 3D CAD system. Some things that are unique about Onshape is how fast we're evolving. So you're going to see new functionality being added to Onshape roughly every 3 weeks. Very powerful functionality, and we're moving very quickly. So you're going to see a lot of new stuff. And the neatest thing from an end user perspective is you don't have to do anything. You log in and there's just new things there for you to check out. So no installs, no upgrades, no files to manage. Now, another thing I like to point out is with Onshape, version control is built in. So you don't have to worry about, what data management system should I have, or who has this file checked out, or who has write access to this. All those issues go away. And also you have the ability to capture major milestones, major revisions in your design with version control. And it's not just major milestones. With our history, every step in that document is captured. So you can think of it as essentially an infinite undo list that allows you to go back and see every step in the process in creating that document. So with Onshape, version control is built in. There's nothing that you have to do separately. It's not a separate solution that you have to manage. It was built into the core from the very beginning. Now, the other thing I like to point out is we can read and write a lot of the common CAD formats that are out there. So if you've come from another CAD system, SolidWorks, Inventor, CATIA, Creo, one of those systems, chances are we can read in your data. Chances are you won't even have to export it. So we can read and write common CAD formats that are out there, even the proprietary ones like SolidWorks and Inventor and so on. So definitely worth checking out. Of course, we can read the neutral formats as well. Step, IGES, Parasolid, even DXF and DWGs can be imported and viewed and modified natively inside of Onshape. So we can read and write a lot of the common CAD formats that are out there. And it makes us a great tool to work alongside an existing CAD system if you have one. We can, a lot of users out there have another CAD system, but they're trying to use Onshape just to share or collaborate with someone. So a question, this is a good question too. Will there be a version for Kindle Fire tablets, since the Kindle Fire is Android based? And that's something that we're definitely looking at. I don't have a projection on as to when we'll have something in the Amazon world, but it's definitely a priority for us. Again, I apologize. I don't have a specific timeline for when it'll be available, but it's definitely on our radar. Question. Ooh, this is a good one. Is there a way to import CSV spreadsheets to drive design parameters? The answer today is no. You can import a CSV. The limitation is, of course, you can't use it to then drive values. Now, this is an area where we hope to improve very, very soon. Something like a data-driven design parameters and things like that is something that we're looking to accomplish very soon. So keep an eye out. But as of today, unfortunately, the answer is no. Okay, the last thing I want to mention, entirely new methods of collaboration. If you haven't shared your document, I know I've already briefly covered this, I definitely recommend it. It's a big share button in the top right corner. All you have to do is enter their email address and define their permissions. So if you want to give them the ability to edit, you can. If you just want to give them the ability to look at it or view, you can. So it's really up to you to define the permissions. But the neat things about our collaboration tools is, unlike a traditional CAD system where you have to open a file and only one person can open a file at a time because of read-write permissions, all those issues go away. This means, 2 or 3 users can work together on the same assembly or in the same document. And so you can have multiple people in the same document working on different aspects of it or even working together. So there is no read-write, there's no check in and out, there is no who has the latest versions. All of those issues go away. And again, the idea is simplicity. You invite them and they're looking the same exact model you are. There is no copies, there's nothing moving around. So definitely recommend sharing your document if you haven't already. A lot of the collaborative benefits of Onshape come in when you start sharing. Question. When you import a SOLIDWORKS file, for example, can you see the feature tree and make edits rather than just exporting a model as a whole? And the answer is no. There's no feature for feature translation between CAD applications. So in other words, when you import a SOLIDWORKS part, for example, you will not see the sketches and features that make up that system. And that's just because we don't have the same exact function of the same exact features. We might do something just slightly different in Onshape, and there's no direct way to map the features from one system to another. So it is worth pointing out all those file formats come in as a solid body. They do not come in as a feature tree. All right, so now let's get into the topic of the day. And of course, the topic of the day is advanced topics. What are we going to get into? Well, we're going to get into really the stuff that we don't cover in the essentials. So sweep, revolves, and lofts. Those are 3 important features. Everyone wants to know, and if you haven't played with them yet, there is some things to understand about them. Also, whole feature, I shouldn't say relatively new, but constantly changing. We've added some updates to our whole feature as of recently, so I'm going to go over that. Also, shell, another very common question, another very commonly used feature, and of course, we have that built right into Onshape. I'm going to walk you through that. Then I want to get into derived features. And the derived features, the idea behind it is, the ability to insert a part into a part. And I'm going to show you some examples where this can really come into play. But very powerful functionality that allows you to build around other things very easily. The last 2 things are very similar in functionality, and that's versions and compare. So as I mentioned before, versions, think of version as a snapshot. We capture a snapshot. Maybe you want to capture revision A so that you can always go back and look at Rev A. We can do that with versions, but we can take it one step further with the compare functionality. So I can compare Rev B to Rev A, or I can compare the design today to the design 6 months ago. And I can see not just all the features that have changed, but a graphical representation of the changes as well. So all kinds of cool stuff that we're going to cover here today. A lot to get through. Probably won't take the full hour, but just a lot to dig through. So, real quickly, question: is there a way to transfer an Onshape model from one account to another? Yes. If you go to the share dialog, you can transfer the owner. That's an option in share. And so you enter their email address, you define them as the owner, and it will transfer the ownership of that document to the other person. So the key thing there is it's in the share dialog. Make sure to specify them as owner if you want to transfer the ownership of a document. All right, so enough slides. Let's dig into Onshape. Now, as I mentioned before, in general, I like to start with sweeps, revolves, and lofts. Those are the 3 important tools. Of course, we have extrude, but we cover that in our essentials. And I'd just like to go over some of the details that are necessary to use those tools. So let's jump into a new document, and I'm just going to create a few new features from scratch here just to show. Okay, we'll call this revolve and sweep. So I'm going to create a new document. I want to walk you through, first off, how to create a revolve. And the way to think of a revolve is a round part. Revolves are used to create round parts. So it's a bit of a different process than what you might do to create a sketch for an extrude, for example. Because what we're doing is we're taking the sketch that you've created and rotating it to create a round feature. So that's the key thing to keep in mind with a revolve. There are a few miscellaneous tips I always like to show with a revolve, so bear with me. But let's go ahead and get started. Now, I want to, of course, start a sketch. So I'm going to go ahead and start a sketch on the front plane. And just a tip in general, if you haven't used it yet, is the right-click menu is very valuable in Onshape. And in this case, I have the option to view normal to sketch plane. Now, you could use keyboard shortcuts if you're a fan of keyboard shortcuts, but it's also a very convenient method in the right-click menu as well. So now I'm in a sketch. I'm on the front plane. I'm ready to start sketching my revolve. Now, the key thing with it is, we're drawing essentially what you might consider like a section or a slice of our revolve profile. So as we're going through this, keep that in mind. A good question, and this is a very good question, and it's something that's very important to us as well. Are there any plans for sheet metal functionality? And the answer is absolutely yes. I would say as of today, sheet metal functionality is our #1 priority. And we hope to have something to the end users very soon, but no promises yet on timelines. But know that sheet metal is, as of today, probably our #1 priority. Now, the other question about sub-D and freeform shape modeling, right now you can find an app in the App Store that will accomplish this. But that's something that we're looking at. The ability, more surfacing tools will be coming soon, but true sub-D modeling is definitely something we're considering. Now you can do this with an app in the App Store today. So if you need that functionality today, you can check that out. But definitely something that we're considering. So, is there a list of all the available shortcuts somewhere? Absolutely. If you go to the Help menu in the top right corner, you'll find keyboard shortcuts, and it will list all the keyboard shortcuts. Now, a commonly asked question, can we change these? The answer is no, not yet. That's another area that we're working. We want to be able to have you be able to customize your keyboard shortcuts and then go to any computer anywhere and have those same keyboard shortcuts. So that's something we're working on. Right now, this is a fixed list, but you can see it's a pretty long list. So if you take some time and learn the keyboard shortcuts, definitely a much faster approach. All right, so back to the revolve. I want to start a simple sketch. And what we're going to do is create, a simple pulley-like part using some basic lines. Now, a tip in general, and this is just a practice. I don't know that it's necessarily a best practice, but it's just something I'd recommend. In general, with revolves, I like to define what is my rotation point. What's my axis to rotate about for this revolve? And in general, I do that with a construction line. So I can select line, and I want construction, and then I just draw a horizontal line. I'm going to draw it right through the origin. Okay. Now that construction line is going to be ignored when we go to do the revolve. Its sole purpose is to define what we're rotating about for the revolve. And that'll make sense in just a second. Now, in addition to this horizontal line, I also want to construct a vertical line. And again, these are solely for my construction, just for my benefit when we start really doing our sketch. But now I have a horizontal line through the origin and a vertical line through the origin. And the vertical line will help me constraints, and the horizontal line will help me to rotate, right, to define what I'm rotating about. So now let's get into the meat of this. Let's start really sketching here. So I'm going to select the line tool, and I just want to start sketching my revolve profile. Now remember, with a revolve profile, it's really like a slice section, often referred to as a section view, or if you've ever programmed like a lathe, for example, where you're programming essentially a half profile of it. It's a very similar approach in that you're really just drawing half. So here's some basic lines, very simple shape for my pulley. Now, a tip, and this is just a general tip, but it's also very useful for revolves and sweeps. Notice as I move my line down here, I'm not getting any inferences. It doesn't tell me, hey, it's horizontal to that point that you drew earlier. You can wake up any inference as you're sketching by moving your cursor over that point and then moving your line back. And now you'll notice I can snap to that point. See how it highlights there? So just a tip, you can wake up any inference to any other sketch geometry just by moving your cursor over it and then moving back. And then you'll see now I have that horizontal inference. And this becomes valuable in a number of situations. I have another situation here. I want it to be horizontal, move my mouse over, wake that point up, and I have the horizontal constraint. Okay, same thing here. And now we have a closed sketch. So again, you kind of have to use your imagination if you haven't done a revolve just yet. But again, think of this as a slice of the part that we're then going to rotate around. Now, the key thing with this is it's not constrained in any way. We really don't know what the size of this model is. It could be, 100 inches. It could be 1 inch. We really don't know. And it's also not constrained the way I'd expect it. And one of the best tips that I can give a new user is if you're trying to understand constraints, left-clicking and dragging to move the sketch around is a great way to understand what's not constrained and what is. And you can see from this model, there's really not a whole lot constrained. So let's get into some of the different constraints that we're going to use. Now, one of the more popular ones that I want to discuss here is symmetry. And it's the reason I drew this vertical construction line. You'll notice as I grab this right line and drag it, the left line doesn't move. But that's the behavior I want. I want this to remain symmetric about that construction line. So what I can do is create a symmetric constraint. So this is just a tip, not necessarily specific to Revolve, but common in Revolves, is you can select the entities. In this case, I want line, construction line, line. So I just left click all three, and then I say symmetric, right? And now when I left click and drag, you'll notice there's symmetry between the lines. They remain centered over that construction line, right? So you'll need to do that in a few places. I'll again left click, left click, left click, and then define symmetric. Okay, one last time. And the important thing here is now when I go and add all my dimensions, it remains centered. And I don't have to add dimensions to cut it in half or do any of those kinds of things. All of that is constructed using my constraints. So now let's add a few dimensions. Now, a few of these dimensions are very straightforward. I just want a width, let's say of 3.5, and I want a width here of, let's say, 5, and I want a width here of, let's say, 0.5, right? Now, when we start talking about the dimensions to define the height, it gets a bit different. Remember, this is going to be a round part. And again, for those just getting started with the revolves, that's a little difficult to understand. It'll make sense in just a second. But how do we define the diameter of this? Essentially what we're doing is drawing like a radial profile of this. How do we get it to show the diameter? And so another tip that I have is if I left click this line, and then I left click the construction line, initially I get that, radial value. But if I move my cursor past the line, it doubles the value and adds a diameter symbol. And that's perfect for what we're doing here because remember, this is going to be a finished diameter, right? So I can left click and let's say 1.5. And I can keep doing this. So I can go next, here, yes, and let's make that 2.75. And here, we'll make this 6.75. And so I can very quickly go through and define all my diameters by using this approach. But just a tip, if you're getting started, move your cursor past the construction line and it doubles the value and gives you a diameter dimension. Okay, and that is very, very common in the case of revolves. So that's a very common technique. All right, so some questions. Forgive me. Do we get a recording of this webinar? Absolutely. You will be sent a link to the recording probably tomorrow morning. We try and get them up within 24 hours. Another question. Can you do a left-click crossing and select all three lines without having to individually select them? Absolutely. You can window select, what's often referred to as a window select, where you just simply left-click and drag a window. Okay? Anything in that window will be highlighted. And if you've come from a traditional CAD system, there is a difference between left or right to left and left to right. So if you are familiar with it, left to right will only highlight the things that are fully encompassed within your window, whereas a right to left will highlight anything touching your window. But absolutely, you can window select and select hundreds of things at once if that's what you're trying to do. Another question. Is there an automatic dimensioning in the sketch? As you're sketching, you're going to see lines appear. And this is a bit of a tangent, so forgive me. But if I just draw a line here, as I'm drawing this line, you're going to see a number appear. And as I let go, I can enter a value for that number and constrain the sketch or dimension the sketch in the same shot. So yes, you can automatically dimension a sketch as you're creating geometry. You draw the entity, you enter a value, enter, and it dimensions it. All right, so I've constructed my revolve profile. This is a real simple revolve profile. I'm ready to do my revolve. It's fully defined sketch. We're ready to go. Now, again, I'm going to select revolve from the toolbar. And what we do is we create a round part. Now, the important thing with this is defining what the revolve axis is. And that's an important step as we're going through this. And if you remember, the first thing I did was draw that construction line. And again, that's not a requirement. It's just more of a practice. But now I can go in and select that line to define as my revolve axis. And now, as soon as I do that, you'll see my finished result. You'll see the finished revolve. So now you kind of get a better idea of what the functionality is, what it does. If you need to create round parts, you certainly can. Now, I wanted to point this out. You have full, which is the default, of course, and it just rotates all the way around to create a full 360. But you can also define one direction 45 degrees, for example, or one, symmetric 45 degrees, or even 15 degrees one way and 30 degrees another way. So you have some flexibility in how you want to define, how far the revolve goes. A question that's come up. I struggle with the plane is far from the part I'm working on. Can you show a way to add a plane normal to the revolve or its helix to making a screw? Oh, this is a very good question. So can you show how to create a plane normal to something? And this is very common in a helix, for example. But absolutely, if you go to plane, you have a few options that are worth pointing out. You have, something like a curve point, which allows you to define a curve and a point, and it inserts a plane normal to the end of that. And that's what I would use if I were doing a helix with a screw or something to that effect, like a curve point. But you do have some other options as well. Something like a point normal might behave in a similar fashion. So definitely worth checking out the custom plane options. Curve point sounds like the one I've tried, just given your example there. Okay, so again, revolve, the key thing with revolve, defining what that revolve axis is. And in my case, I actually sketched one in. If you have an inference for a line or you have a line that will work, that works just fine too. But you need to define what is this sketch rotating about. Okay. So that's our simple revolve. Now, the next one I want to cover is a sweep. And so let's jump in. I'm going to create a new part in my document, and we're going to start a whole new sketch. Now, the key thing with a sweep is they require a profile and path. So there's really two pieces to a sweep. And oftentimes it means two sketches, right? Two separate sketches. Not always, but oftentimes. So what I'm going to do is, again, start a new sketch on the front plane. And I want to start with my path. A very important thing to point out. Again, not necessarily written in stone that you have to do it this way, just a best practice. But I want to start with a path. And what we're going to do is we're going to create like a simple U-bolt shape, right? I want to create a simple U-bolt. So I'm going to start with a line. And I want to start at the origin. We'll draw a vertical line to right about there. Then we'll do a tangent arc. Okay. To right there. And then we'll define another line. Okay. Again, simple U-bolt shape. So once we've defined it, we'll add just a few dimensions. Okay, so let's define a distance dimension here. Let's make that 3.5. And we'll make this distance, let's say 3.5. Okay, so I've fully defined this sketch. And of course, it's really just a line, arc, and line. But remember, this is the path that our sweep will follow. And that's the way to think of it is You're taking a shape and you're sweeping it along a path. In this case, we're sweeping it along this U shape. So I can hit the green check. We finished our first sketch. Now, with a sweep, often it involves 2 sketches. So I'm going to create the second sketch. Now, a tip. In this case, you'll notice that I put the end of the path right on the top plane. So if I go back real quickly here to the front, notice that the end of the path happens to end right exactly at the front plane, or excuse me, the top plane. So the reason that's important is because I do not have to insert a plane. So if you don't have this, if you don't have a default plane available to you, you'd have to insert one using that same curve point option I showed you a moment ago. So I can select curve point, select the line and the point, and it'll insert a plane normal to the end of that line or helix or whatever the shape is. But very important thing to point out as you're getting started, in this case, it happens to work out well. I put it right on the top plane and I don't need to do anything. But you may need to. If your geometry doesn't end perfectly on an existing plane, you'll need to create one. Okay, but I don't. So we're going to jump on to the next step, which is my profile. So as I mentioned before, the U shape is our path. This is our profile. And in my case, if you think about a U-bolt, it's really just a circle swept along that U shape, right? So we're going to draw a circle. I'll attach it to the origin here. Actually, let's deliberately bring this out. Okay, and I want to dimension it. Okay, we'll add a 0.5 dimension. Okay, so now I have a circle and it has a 0.5 dimension, but it's not attached to my U-shaped sketch. And I deliberately did that just to show you how to do this. Of course, I could have just attached it to the origin, but you may not have the origin easily selectable. So what do you do in those situations? You create a constraint, right? So let me walk you through that. Now, the constraint is very simple. In this case, I want the center point of this circle pierced to the point where this line intersects my plane. I want it attached to the end of this line. I'm going to use the pierce constraint to accomplish it. So I can select the point and then the line and then define them with the pierce constraint. Okay. What that will do is it will ensure that the center point of my circle is at the exact point where that line hits my plane. It's perfectly centered. Very important, you want your profile attached to the path. You can use pierce or coincident, and in this case, they both work the same. But very important, you must attach them. You wouldn't want it floating out in space. You'll get odd behavior. So now we've got it, right? We've got our profile, we've got our path, and we're ready to move on. So we've got our 2 sketches. I'm going to go ahead and accept. And now I'm ready to do my sweep. So I select sweep from the toolbar. I select the circle. So my first step is to define the face or region that I want to sweep. I'll select my circle. Okay. Then I define the sweep path. Now a tip. You can go in and select individual lines within the sketch. So you don't have to sweep the entire sketch if you don't want to. However, if you want to, and you have maybe dozens of lines and arcs and things like that, going in and selecting individual entities isn't the ideal scenario. So a tip is you can select the entire sketch from the feature list, right? And so you don't need to do, forgive me, sketch 1, you don't need to go in and select individual entities to sweep along. If you have, a few dozen lines and arcs and so on, it's not really practical to go in and select them individually. You just select the entire sketch from the feature list. And that's it. You define the circle, you define the U-shaped sketch in my case, and you'll see we have a sweep. And again, you'll kind of get the idea is all we're doing is we're taking that circle and sweeping it along the path sketch. Okay. So green check OK, and there is our sweep. Okay, a few questions, but can you just dimension the center of the circle? The question that came up earlier, can you just, a question relating to what we were talking about earlier, can you just dimension to the center of the circle? Yes, you can add a dimension. And let me go back real quickly here to sketch 2. instead of constraining it. However, this is not the best technique, and there's one big reason for this. If I did not constrain this with a pierce constraint like I did, if I change the first path sketch, the dimension does not update. But if I constrain it like I did here, it automatically updates. So yes, you can dimension it, but it's not the best technique. And the reason is it will not update if you changed sketch entity, if you change the initial sketch. Okay. Question: how would you then add threads to the end of the U-bolts? And the threads are a bit of a different topic. I don't want to spend too much time digging into threads, but just real quickly, the process of creating a thread I can cover very quickly. I'm not going to go into too great a detail, so forgive me. But the key thing with a thread is defining a helix, right? So you define a helix. You can say, okay, I want to use that face as my reference. I want to use pitch, and we'll say 1 divided by 12. So I want a 12 pitch thread, right? Green check. Now I've got a helix. The next step for me is to sweep a triangle along that helix. Okay, and again, I don't want to go into too great a detail here. We'll just create simple triangle. And of course, it's a thread, so it should be an equilateral triangle. And we'll define 1 divided by 20 is 0.05. Okay, so we'll define 0.05 as my dimension. Actually, let's make it just slightly less, 0.045. And of course, I want to attach it to my helix. So just like we attached the circle to the U-bolt, I need to attach this profile to my actual helix. And we could do this a few different ways. You might use a pierce constraint like I did there, just the same way we did with the circle. But then you can do, something like a sweep, remove, and then use the thread and then your helix as the path, right? And that will actually go in and cut the threads into your part. Okay. Now you need to know the pitch, you need to know the difference, between them and define the pitch and so on, but that's the general process that I would use to create a thread. Okay. All right, so that is, we've covered so far revolve and sweep. The next one on my list is loft. Now, loft is definitely its own animal, and really, I very much consider loft the last resort. If you can get it done using an extrude, revolve, or sweep, it's going to be faster. But there are certain shapes you just can't create using one of those three tools, and that's where loft comes into play. Situations where it's more of an organic shape than it is a circle or a boss or so on, you can use something like a loft. Now, the example I like to give with this is this squeegee. So you'll see here, I have a squeegee, and I don't have anything joining the handle to the base here. And there are a few things I want to point out about lofts in general. And I want to start with kind of the basics here. So I'd like to start, we'll hide the sketch I've created. So all I have is a face and a rectangle to loft to. Now, one of the first tips I can give you is if you're just lofting from a circle to a rectangle or some very different shape to another very different shape, you may have loft twist. And I like to take this opportunity to explain that. So I'm going to select loft. And the key thing with loft is you're lofting between profiles. And you can loft between as many profiles as you'd like. I only have 2 in this example, but imagine you're building like a boat hull, for example, and the transition is constantly changing from front to back. You may have dozens of profiles in a part like that. So you have a lot of different capabilities here. In my case, I'm going to keep it simple. All I want to do is I want to loft from this face to my rectangle sketch. Okay, so I'll select it from the list. Some things I want to point out about this. The first is notice the twist. So just real quickly, by default, when I go from something like a circle to a rectangle, you may end up with twist in your loft. And the reason is because it doesn't know how to map the point from the rectangle to the corresponding point on the circle because, again, there isn't any points, right? A circle is one entity. So just keep in mind, with something like this, you have a few options for cleaning this up. Obviously, this is not what I want, right? So what can we do? And there are a few solutions to this that I want to discuss, but one of the easiest is using what we call split entities. So I'm going to go into Sketch 5 here. I'm going to edit Sketch 5 and just take a look at this. Now, this was just a simple circle. All I did was draw a circle. The difference is I then went in and split the circle into 4 pieces. So this is the tip. And what it does is it gives me the same number of points on each loft profile. Rectangle has 4 points. I split my circle into 4 points. And what this does is now when I go to loft, it automatically knows which points to match to which, right? So this can make it very easy and allows you to create a much smoother transition. So let's take a look. We'll do a loft between something like Sketch 5 and Sketch 16. Okay. Notice how clean the loft is compared to the last example, right? So there's not nearly as much twist in this loft as there was just a second ago. Okay. Now, this may not be the end all. Maybe this isn't quite good enough. And that, this is one step closer. But if I want the ultimate control over my loft, then we get into some of the in condition options, right? We have guides and in conditions, right? So if I want to control the shape in a little bit more detail, I can add something like an in condition and define, perhaps normal to profile and extend that a little bit further. Okay, so you'll see now it's extending normal to profile for slightly longer, and I can even change the magnitude of that, okay, making it very sharp. Notice now it's extending even further out before it transitions to the rectangle profile. So a simple way to really control the contours is to use something like in conditions. However, if you want the utmost control, all the detail in the world, you can use guides. Now, guides will take you a little bit longer to set up, but they're very, very powerful. And the reason I say that is because essentially what you're doing is you're controlling the transition between shapes, not with in conditions or with splitting entities, but with actual sketch geometry. So here I've turned on my guides. You'll see there's guides going from each point in my circle to each point in my rectangle. But the important thing here is now I'm very accurately controlling the transitions, right? So let's jump back down into the loft here. And if I edit it, you'll see I've turned on guides and I've selected each of the 4 guides that make up this loft, right? So each of the 4 corners, and now my loft is following those lines or those contours exactly, right? I don't have to make it match within conditions, or I'm not trying to, guess. It's a very accurate way of doing it. Now, of course, this is 4 separate sketches with 4 separate sketch entities, so it is going to take you a bit more time, but if you're looking for the utmost control, this is definitely the way to do it. Now, another tip, and something that's just really neat and it's kind of baked into the default functionality of Onshape, is if I go into one of these guides, let's say I edit this sketch, we have this button here called Final. So when you're in a sketch, and this isn't specific to lofts, it's everywhere in a sketch, if you check Final, it will actually turn the finished feature on. And the reason this is so neat is then I can go in and say, okay, well, let's drag this up and see what it looks like. And it will dynamically resize the loft as I'm editing the sketch. So it allows me to see in real time what my changes are. I don't have to change the sketch, rebuild and see what it looks like, then go back and edit the sketch, rebuild and see what it looks like. And going in and out, I can just turn on Final, move my sketch around, and I can see it update live. Okay, so I think it's really neat to show that for guides, but you can do that for extrudes, revolves, sweeps, lofts, whatever you want. You just turn on Final and it gives you a final preview. So that is the final, and that is lofts. In general, I'd recommend if you want the utmost control, make sure you have the same number of vertices between profiles so you can split them up. And if you really, really want a lot of control, guides give you that. Now, in conditions, can do a lot. So in conditions are simple and they give you quite a bit of flexibility, but guides are kind of the ultimate. So, all right. A couple of questions, forgive me. Is there 3D sketching capability that can be applied to sweeps so that there's one 3D sketch as a path? The answer is we do not have 3D sketch capability as of today. That's something that's also very high on our list of priorities. You can accomplish this using a combination of 2D sketches, but it's certainly not ideal, and it's something that we hope to improve very soon. Next question. How do you draw the 3D lines for the guides? And this is a very good question. In this case, there's planes. So if I look closely here, there is a plane that was inserted between these 3 points, right? So I did a plane. We chose 3 points, and then I just use 1 point from the circle and 2 points from the rectangle. And it creates a plane that goes right through them. And then I can use that plane to construct the sketch that you see here. Okay. So yes, I did insert a plane and then just create some simple profiles on that plane. Okay. Again, that's how the guides are drawn. Insert your planes. In this case, the guides are just splines from one point to another. The neat thing about splines is I can grab the handles and manipulate and dynamically see it update. All right, so let's move on. Now that's Lofts. The next thing that I wanted to cover is the shell command. Now the shell command allows me to essentially create a hollow part. It takes what would be a solid part and gives it uniform wall thickness. Now there's a number of useful examples where shell is valuable, but I think one of the most common examples is something like an injection molded part where uniform wall thickness is critical, where I need to have the same wall thickness throughout the part. But really think of a shell as, I'm trying to create a hollow part in general, right? Okay, so I want to select the shell command from the toolbar. Then I select my face to remove. Now, in this case, you don't have to. If all you want to do is create a hollow part and not remove any faces, you can just check hollow and then select the part you want to make hollow, right? However, in this case, in my loft twist, in this squeegee example, I want to remove this back face. So I'm going to left click that face, and then it goes through and it tries to shell out the entire part. So as I rotate around here, you'll see that part is now hollow all the way through it. Okay. So that is the shell command. You define your wall thickness here. You select any faces you want to remove, and that's it. I hit the green check OK, and now I have a shelled part. Question, can you project a pair of 2D sketches onto another to create a 3D curve? We don't have a project for sketching these, but I have seen others use surfaces to accomplish the same thing. So absolutely, we can use something like 2 surfaces that are joined to create a 3D sketch entity that can be used for a sweep. So there are ways to accomplish this. I would use like surfacing tools. There's lots of great examples. A good example I'd like to point out is there's a mouse in the public documents where the user took 2 surfaces, joined them together. That creates a 3D contour, and they use that to generate the sweep. So there are ways to accomplish it. Question, could top and bottom guides be drawn in one sketch? I believe so. I don't think there's any limitations there. They don't need to be in their own sketch entities. I'm fairly certain. Forgive me. I'd have to test that myself. But you should be able to select any piece of the sketch and define it as a guide. More than 2 profiles for Loft is possible. Absolutely. You can create as many Loft profiles as you'd like. We have customers that have built boat hulls, for example, and they have 20, 30 different profiles. You can have as many as you'd like. Is it possible to create a shell with different wall thicknesses? This is a very good question. You do not have a thickness setting option in the shell, but what you can do is separate the 2 parts and shell them independently and then just merge them together. So we have great Boolean tools, and we have the ability to define, I could say, this is a separate part than the handle, shell this and this separately, and then just do a Boolean to join the 2 back together. So there are ways to accomplish it. It's not a checkbox option, so to speak, but it wouldn't be a hard workaround. So. Okay, so how was the handle made? It was made with Lofts as well. So the handle of this squeegee was constructed with just a series of profiles. So one profile here, one profile here, with a guide that defines the grip. That's the finger grooves that you see in the grip. That was defined with a guide. So Almost the entire part is lofted. The only thing here is the base, where the squeegee actually is. That's just a simple extrude. Okay, so we're getting near the end here. I wanted to move on. That is the shell command. The key thing to keep in mind, you select any faces you want to remove and you define your thickness. And that's really all there is to it. Let's move on. Now, the next thing I want to cover is derived parts. Now, derived parts are useful in a number of different scenarios. It's not just what I'm going to cover here today. I could give you a dozen examples where this is valuable, but I always like to show what I think is probably one of the most common scenarios, or one of the more popular ones. So let's just say that, I've got two parasolids from a vendor, two totally different files. I need to put these files together and then build a part around them. And this is a common workflow. Maybe I'm getting motors from my vendor, I'm getting some bracket from someone, and I'm trying to piece all this stuff together to build my part in around these things. This is a great example where derived features make a difference. So here I have two parasolids. This is a bottom casing and a top casing. And it's translated, of course, Onshape automatically translates. So here's the bottom casing, here's the top casing. These are imported parasolids. My problem is I need to bring these two pieces together, and then I want to make a flange that attaches to those two pieces. All right. So this is where we'd use a derived part. I'm going to go into Part Studio 1. Okay. And let's go ahead and delete these, walk you through it. I'm going to select the derived feature. So you'll see on the far right of the toolbar, derived, and you can browse to any part, sketch, plane, helix, any of those things in this document. So I can say, okay, let's start with the bottom case. We'll insert the bottom case into this part, all right? And I'll do it again. This time, though, we'll insert the top case. So now I've inserted two totally different parasolids from, maybe even different vendors. I put them in one Part Studio together with the derived feature, and now I can build my flange, right? Now, one tip that I have is, you'll notice in this example, everything comes in real clean. The two parts are perfectly mated together like you'd expect in real life. And that's because that's the way they were modeled. They were built with that relationship relative to the origin. If your parts aren't, you may need to do a transform and move a part around. So that's a tip. You can use transform to manipulate your parts around and then actually go in and once they're in the correct position, make your part. So now let's do that. Now I want to create a simple flange. I can use the faces of the parasolid. I can even attach constraints to sketch or to entities on the parasolid so I can attach it to the end. Here with coincident, we'll do another circle. Okay. And I can attach it to the end here. Okay. And I can even convert the holes of this part. All right. So I can select all holes and select the use command and convert that to sketch entities. Okay. And so I can really quickly, and notice I didn't add one dimension. This entire sketch is driven by the parasolids that I've imported. And now I can extrude. We'll punch in 0.5, and I've built my simple flange. Okay. Now the key thing with this is it's a derived feature, and what that means is if you change the original, this updates. So let's do that. I'm going to jump back into my bottom casing. This is just the single part, and we'll do a move face. Now, if you haven't played with any of the direct editing tools, they're great for scenarios like this, where I have this parasolid that I've imported. I don't have any features, but I need to make a change. I can select move face. We can do a simple offset. I'll select the face I want to offset and then punch in my value for the amount of offset. Okay. So now we've made the hole going out of this bottom casing 3/4 of an inch smaller, right? Green check. And now you'll see that hole is much smaller. Let's do this one more time to the top. Again, I'll do move face. I can select the face. We'll do an offset. And again, I'll do a 3/4 inch offset. Okay. So all I'm really doing there is making the hole smaller. And the question often comes up, could you have done that in the other Part Studio? The answer is yes. It's important to keep in mind, though, in this case, these are kind of the masters. They're the key to it all. And when I go into the Part Studio, they will update. And I think that's the critical thing I wanted to stress. Notice that the hole on my flange is now much smaller. And that's because it was attached to those two parts, and those two parts got much smaller, right? So it will update. And I think that's the key thing I wanted to point out. That's the key thing with derived features. Question: Can you can create patterns in part files, but can you create patterns in assemblies? We don't have a pattern button. We do have what we call replicate, and that's what I would look into. Replicate oftentimes can be much more powerful than a typical pattern. I would definitely check out the replicate command in assemblies if you're trying to pattern parts in your assembly. Now, of course, we have pattern tools at the Part Studio level as well. So we have linear and circular patterns to do patterns of parts in the Part Studio or features. But in the assembly, replicate is the command that we'd use for that. All right, so we've covered derived features. The last thing I want to mention here today in these last couple minutes is versions and compare. So I'm going to jump into an example here of compare. Now, I have a real simple part, but this goes into complex part studios and even assemblies. You can do a lot of cool stuff with versions. So the first thing I want to mention, again, version control with Onshape is built into the core. You don't have to have a separate data management application or something to manage it separately. So let's just say that, I wanted to capture a major milestone. Let's say that this is my revision A or revision B. I can go to the versions toolbar and hit the big save version button. And what this does is it captures a snapshot of the entire document. Not just this part, but any assemblies, all parts, even things like PDFs and text files and images are all version controlled. So the entire document gets snapshotted. It creates a snapshot of the entire document, and you can always go back and look at it. I think that's the key thing. If I'm 6 months ago, I created revision A, now I want to go back and look at what did revision A look like, or I want to download a PDF of the part at revision A. You can do that. Create a version, and you can always go back and look at it. Okay, so version's very easy to create. You have save version, you give it a name, you hit the big save button, and now you have a snapshot of the entire document. You can go back and look at it at any time. Now, I've already created one. So if you look at this, I've already got revision A in this document. Now, if I left click revision A in the list, it loads. So I mentioned before, how do we go back and look at revision A? Just left click on it. And you'll notice there's quite a bit of difference. This boss is substantially smaller. These cuts are quite a bit different. The part itself is shorter overall. So there are some major differences between revision A and the current state of my part. Now, this is versions. Again, it just captures the snapshot and you can go back and look at it. But one thing I always like to point out about this is you can also compare two versions or even two moments in history. So I can say, okay, well, let's take a look at the way the model stands today versus revision A. And I want to compare the two. And the way you do that is, in this case, the main or the current version is highlighted. And if I go down to the gear menu under revision A, I have the option to compare. So I select compare, and it does a comparison. Now, this is really neat for a number of reasons. The one I'd like to point out is you get not just a graphical preview of the differences, you actually get a feature by feature breakdown of the differences. So I can go in and say, okay, sketch 1 is different. It tells me sketch 1's different. If I select extrude 1 is different. And it will even tell me what the distance or what the differences are. So I can see in the main version, I have 20 millimeters extrude. Revision A, I have 22 millimeters extrude. So the depth is different in each version. And I can take it one step further. I can go in and let's select the fillet here. I'll select the fillet, and it shows me in main, there's only 4 edges, and they're at 4 millimeter radius. But in revision A, there was 6 edges highlighted, and there were 5 millimeter radius. So you're getting a very explicit breakdown of the differences between major milestones. And you could do this with versions, you could do it with branches, you could do it with moments in history. Very cool stuff. And it also shows you, by the way, not just what's different, but what exists in one and not the other. So here's a fillet that exists in revision A, doesn't exist in main. Here's a chamfer that exists in main, but doesn't exist in revision A. So you get a real explicit breakdown. So this is neat. Now, the next thing I want to point out is it's not just a list, you get also a very nice slider. So I can graphically tell the difference between the two that I'm comparing. Right? And I can grab that slider back and forth, and it gives me this really nice animation, making one transparent over the other, and really cool stuff that allows you to graphically see the differences between each version. Okay. So that is the compare tool. Again, you can use it for versions like I've done here. You can even go back into your history. So I can go back, let's go back into, some moment in my design here. I can go way back to, 6 months ago, choose a random spot in my history and say, let's compare that, right? So I can go back 6 months ago today and say, let's compare the design today to 6 months ago using history. And you can even do it using branches as well. So really cool stuff, definitely worth checking out. But the main things I want to stress, you can create a version and it captures a snapshot. So you can always go back and look at it. You never have to worry about hunting it down or figuring out where it's at in the history. And you can compare those versions both graphically and with a list. So that is what I had planned. I have just 2 minutes left, so bear with me. I have one last thing I want to mention, then I'm going to get to any outstanding questions. If you're just getting started in Onshape, we really encourage you to try Onshape in your professional work and let us know what you think. Use the feedback tool. Let us know what you think of Onshape. And, is there anything missing? Is there anything you'd like to see? Is there anything not behaving the way you'd expect? Let us know. The feedback mechanism is built right into Onshape. It's in the help menu, and it's really easy to use. You don't need to log in. You don't need to give us any details. You just type in some comments. If you want to grab a screenshot, you can. And that's it. You hit a big send button, and it's an entirely closed loop. We create a ticket. We send you emails to notify you about updates to the ticket, and we send you an email to notify you when it's been resolved. So closed loop system, really, really taking user feedback very seriously. So definitely use the feedback tool and let us know what you think. Also, if you haven't already, we really encourage you to invite others and share your document. There's a big share button in the top right corner. You hit share, you enter their email address, define their permissions, whether you want them to be able to edit or just view, and then hit share. Even if they don't have an Onshape account, we create one on the fly and then send them a link. So it's very easy for you to share with someone, and then they can jump in and look at the same exact model as you at the same exact time. If you give them edit permissions, you can even edit the model at the same time. You could build assemblies together. You could edit parts together. The last thing I want to mention is if you're interested in establishing a user group, we'd love to hear from you. We've reached a point now where we're meeting users who are interested in meeting local users and giving feedback and tips and tricks about how to use Onshape. If you're interested in establishing or running your user group, we'd love to help. So let us know. So that's what I had planned. Again, I'm going to stick around and answer any questions that you have. So feel free to type in anything in. And but that's it. Thank you, everyone, and have a good day.